Hi everyone, this is Ashwin here. In this video we are going to see about what is linked list. So we are going to see about the definition, advantages, disadvantages with this application. We are also going to see about the visual structure, how it represents and what all the things are there in the linked list. So we are going to see everything about this. Let's start with the definition or properties of linked list. So definition. So the first one is it's a linear data structure which contains finite sequence of nodes. And the second one is in linked list, the elements are not stored in a contiguous memory locations. So in array we have seen the elements are stored in a contiguous memory location. So we can able to access it very quickly using the index. But here it's stored in a different memory locations. And the third one is elements are linked using pointers. So if you want to go to the next element means we can able to only go to the next element with the help of pointers. So there will be next pointer if you want to go to the next element. In some types of linked list there will be previous pointer, so we can able to go both forward and backward directions. It depends on the types of the linked list. And it has a finite sequence of nodes, as I said in the first point. So it is very limited and it is used for multiple applications. So these are the definition or properties of the linked list. Now we have seen the definition of linked list. Now let us see the visual representation of linked list. So I will just draw two nodes quickly so we can able to see how it looks. So I have drawn two nodes. So this single structure is considered as a node. So I will place some elements. So this is the data and this is the pointer. This pointer is points to the next node. And after this there are no pointers. So this is null pointer. So we have no nodes after this. So I will represent what are the terms in this linked list. So this is just the size of 2. So this is the data. So data, this is the next pointer. Next pointer, and the start of the node is considered as head pointer. So this will be head pointer. And this whole thing is considered as a node. So this will be node. So this is the simple representation of the linked list. So this starting point is considered as head, and the pointer that we have used to traverse to the next, that is called the next pointer. If we want to traverse to the next element means we can able to use this next pointer, and it also contains the data value. Here the data value can be anything. It can be a string, it can be an integer, it can be a character. So the data can be anything. It can be a class also. So it depends on your use case. And I just showed you an example for a singly linked list. So this is how it look like. Now we will see how the algorithm or the initialization of linked list or node look like. So I'm just going to show you how the initialization of the node class look like. So class node. So if I consider some Java syntax, it will look like this. So it will contain the data. So I'm just considered as integer. And the second one will be the next pointer. So that will be node next. So this is somewhat the closer representation of all the languages. That's why I used this. Now when you initialize a node, at that time we will point that first initialized node to the head pointer. So using this only we can able to traverse from the start. And apart from these things, we can able to see what are the types of linked list. So the linked list have three types. The first one is singly linked list, and the second one is doubly linked list, third one is circular linked list. So in singly linked list, the representation will look like this. It have only one pointer that can able to traverse to the next node. In doubly linked list, we will be having one more pointer to the available data, that is a previous pointer, so we can able to traverse both forward and backward. And in circular linked list, the end pointer will be connected to the start. So that is the difference between circular linked list. So circular linked list can be implemented by both singly and doubly linked list. So these are the available types of linked list. Now we will see about some of the advantages and disadvantages of using the linked list. Now let us see the advantages of linked list. So the first advantage is it has dynamic size. So dynamic size means in arrays we have a fixed size. So initially we have to fix the size and we can't able to grow. But here we can able to assign a new node and increase the size dynamically. So that is the main advantages of using the linked list. And the second advantages is ease of insertion and deletion. So when we are trying to insert an element in the linked list, it will be much easier compared to arrays. So in arrays, we have to shift all the elements to left or right. It will be somewhat tedious to insert or delete. But here, you just have to allocate or reassign the pointers in order to insert in the middle, end, or beginning. It can be any place, but both of these operations will be much easier in the linked list. So these are the advantages. Let's see the disadvantages now. So the first disadvantage is random access to elements is not allowed. So in arrays, we can able to randomly access the elements using the index position, but here we can't able to randomly access the elements as simply as arrays, because we have to traverse each and every element in the linked list in order to reach to some particular data. So that is a major disadvantage. If you want to access the last element, means you have to traverse from the start to the end. So that is a major disadvantage. And the second disadvantage is it needs to have extra memory space for pointers. So extra memory space for pointers. So if you remember, in arrays we would have saved only the element, that is the data, but here we would have that next pointer. In doubly linked list we need to save two pointers. So additional storage needs to be done if you want to implement linked list. So that is another major disadvantage. And the third one is traversing is time consuming. Why it is time consuming is because for every operation we have to traverse the linked list. Even for insertion at the middle or at the end, means you have to traverse from the start to the end. So that is more time consuming compared to arrays. And the last one is it has less cache locality. What it means is in arrays we will be having some fixed memory locations, so it can able to reuse the location again. But here we are allocating the elements in a dynamic space. So if some pointer is allocated somewhere, means another pointer will be pointed to somewhere the other part of the memory. Like that it will be handling the memory allocations. So I will show you how the memory allocation works in a simple diagram. Let us place this now. So I will quickly draw some physical memory now. So I will say memory. So now I have drawn some memory locations. So if I consider the pointer 1 is located here, so this will be the head pointer. So the next pointer will be pointing to some other memory location. So I will point it to here. So this is the next pointer. It is pointing to some other address and the element will be here. This is 2. So it's not stored in a contiguous memory location. If this 2, it can able to go to some other memory location. So this will be the next pointer of this. So this will be the next pointer of this. Like that, it will keep on going. It can be if it's a free space means it can able to allocate in the next element. But if there is some occupied elements means it can able to allocate anywhere, because we are going to just save the memory location in the next pointer. So I will mark this will hold address. So the next pointer can able to hold the memory address. So we can able to traverse to the next memory location. So this is how the linked list actually works in the backend. Now after saying everything, let's also see the applications of linked list. So applications. So the first application is we can able to implement stack, queue, graph, etc. with the help of linked list. So implementation of stacks, queue, graph, etc. Similar to arrays, we can able to implement all these other data structure with the help of linked list. And the second one is maintaining directory of names. So this is also another application. Third one is sparse matrix representation. Sparse matrix representation. And the fourth one is it can be used for image viewer. Image viewer. What it means by image viewer means, so we already using it in a real-time application. If you want to go back and forth between the sequence of images means, the linked list will be very helpful. Even if you add more images means, we can able to dynamically go both forward and backward with the help of doubly linked list. So this is one of the real-time application. And the other one is music player. So in the music player also we have n number of songs. It can be in a list and we can also rearrange the songs if we want. So we can also use the same operation as I mentioned in the image viewer. So these are some of the application. So and sparse matrix, in sparse matrix most of the elements will be 0, but we can able to change and store some of the elements with the help of linked list. So directory names you already know by the statement itself. So these are some of the applications that will be very helpful in real-time use cases. Let's store it now. Now we have seen all the things about linked list. So this is the introduction. After this we are going to see all the operations that are available in the linked list. So we are going to see insertion, deletion, some of the questions that are asked in the interview process. So we are going to see everything. I think that's pretty much it, guys. If you have any queries related to this video, please leave a comment below. Other than that, if this video is helpful to you, hit the like button and don't forget to subscribe the channel and share the video to your friends if it is helpful. Stay tuned for the next video.